we're going to do in this video is look at linear equations, and specifically two key components that make up a line, a y-intercept and the slope. Those two pieces can help describe any graph of a line as well as any actual equation for a line. So to start off with, let's look at this equation y equals 2x minus 3. What we're going to do is just plot some points and see how a line comes through. So we have these x coordinates, and what we want to do is just grab some y coordinates by using that 2 times x minus 3. So if we plug in a -1, we'd get out a -5. And if we had 0, it would be a -3, and so on and so forth. And what this will do is give us 5 coordinates that we can graph. Now when we make this graph, what we should see is a perfect line coming through, meaning once we have these 5 dots, if we put a ruler down on the paper, it should perfectly line up with each of the dots for our graph. So once we have our dots, then what we can do is see how it makes a line and connect the dots with a straight line. And then we could put arrows on our line to show that it goes on forever and ever. So right here is a line coming from a linear equation. Let's see where y-intercept comes from. So if we scroll down below, y-intercept is usually described by the letter b, and it's where we cross the y-axis. And it comes through as a coordinate. It's a coordinate where x is equal to 0, and then we'll have some y coordinate, but that y value is what we use for this letter b. So if we look at our graph, our y-axis is this vertical axis right here, and what we want to do is see where does our graph intersect with that axis, and that's what's happening right here at -3. So we have this coordinate right here, and we can see it on our table as well, where x is equal to 0. That will be our y-intercept, the coordinate 0, -3. To see how that shows up in our actual equation, y equals 2x minus 3, it shows up as the constant term in our equation. So our equation has 2 terms to it. We have the 2x and the -3. And with linear equations, you're going to see a term that has x with it, and then a constant term, and our constant term is going to link to our y-intercept. Because that's what's going to be left over when we plug in 0 for x. Now if we look for the slope, we use the letter m to denote slope, and there are many different formulas for describing slope. But what it comes down to is describing change in y divided by change in x. Now, this is how we move between 2 coordinates on the line. So change in y, if we think about how y can change, y is our vertical axis. So if we had to stick on that y-axis, all we could do is move up and down. So our change in y is going to be this movement up and down. And what's going to happen is if we're moving upward, our value is going to be positive. If we have to move downward, our value is going to be negative. Then what we'll divide by is the change in x, which if we look at the x-axis, that's our horizontal axis. And if we were stuck on that axis, all we could do is move left and right. So it's going to be how we move horizontally. And how we move horizontally can only go to the right or to the left. If we move to the right, that's going to be positive. If we move to the left, that's going to be negative. So let's see how we find slope for this graph. What we need are 2 coordinates. So let's say we start at 1, -1, and we want to describe how we're going to move to 2, +1. Well, to move over there, in terms of moving up and down, I'm going to need to move up 2 units. So I have this movement upwards, so it's positive, and I've covered a distance of 2. And then to finally get to that coordinate, now I can move left and right, and to get over there I need to move to the right, and moving to the right is positive, and we had to go a distance of 1. So the blue number gives us our change in y, so our slope's going to be a positive 2, and then for our denominator is our change in x, which is coming through as the red number, which is a positive 1. So this is going to have a slope of positive 2. And if we look at our linear equation, that number comes through as that number multiplying with x. So that slope is going to come through as the numerical coefficient of x. And those will be the numerical values that show up in linear equations whenever we have y isolated and everything simplified. There'll be 2 numbers, one will be slope and one will be our y-intercept. So this describes our slope-intercept form. It's going to be y equals slope times x plus our y-intercept. So let's look at 2 more examples where we work with graphs and our linear equations. So here we have an equation given to us, and we want to identify the slope and the y-intercept. So here's our 2 terms. We have the negative 1/2 x, and then we have this positive 4. So for our slope, it's going to be the numerical coefficient on x, which is the negative 1/2. And the y-intercept is going to be that constant, that positive 4, which is really describing a coordinate to me where x is 0, and we're getting a positive 4 out. So using those 2 values to make a graph, what we want to do is start with the y-intercept, because that's giving us a coordinate. So we can immediately go and graph our point 0, 4. Then what the slope does is it gives us a map to follow in order to get a second coordinate out. So if we look at our slope, and let's put it as negative 1 divided by positive 2. When you have a negative slope, the negative can go into the numerator or the denominator. It really comes down to thinking in terms of up, down, right, left. So you want that negative somewhere to see, are we moving down or are we moving left? So with the structure like this, that numerator, since it's negative, it's telling me to move down 1 unit. And that positive 2 is telling me to move to the right 2 units. So if we follow this, we start at our point 0, 4, and I move down 1 unit. So I follow that path, and then it tells me to move to the right 2 units. So I follow that path, and once we end up at our spot, that's our second coordinate. And you only need 2 points to make a line. However, we could keep mapping the slope down 1, right 2, and we could get out more coordinates if we wanted to. But then we connect those with a line. And there's a graph of y equals negative 1/2 x plus 4. So start with your intercept, and then just follow the map that the slope gives you of moving up, down, left, and right. For example 3 here, what we have is a given graph, and we want to find the slope and the y-intercept. So what we can do is start with the y-intercept. It's going to be easiest to find as our intersection with the y-axis. So our y-intercept is going to be 0, negative 3. And then what we need to do is find a second coordinate. So if I start at 0, negative 3, it looks like here's a nice coordinate at 2, positive 2. And what I need to do is figure out how can I get there. So I need to move up, and it looks like I'm moving up a distance of 5. So we're going to have a positive 5. And then move to the right 2 units. So I'm going to move right, so that's positive 2. So for slope, we're going to have a positive 5 over positive 2. Now that I have those 2 pieces, I can fit my y equals mx plus b form by substituting in for m the 5/2. And then for the plus b, I'm going to have a -3. And that would be our equation for the line. That's how we use slope-intercept and using slope-intercept form to describe linear equations.